Hi class, this is course 3, lesson 68, the probability multiplication rule. Okay, so the fundamental counting principle is one that you're familiar with, and that just says that if an experiment has two parts, the first part with m possible outcomes and the second part with n possible outcomes, then the total number of possible outcomes for the experiment is the product m times n. So you multiply the ways that the first thing can happen with the ways the second thing can happen, and you get your total outcomes. So to illustrate that, if two number cubes are rolled together, how many possible outcomes are there? Well, you can use a tree diagram and say, well, I could get a 1 on the first one, and then I could get a 1, a 2, a 3, a 4, a 5, or a 6, and I could get a 2 on the second one, on the first one, so I could get a 1, a 2, a 3, a 4, a 5, or a 6, and you can keep going with a 3 and a 4 and a 5 and a 6. But each time you do that, how many outcomes are there? There are 6. Okay, so I know that if I make the tree diagram, there's going to be 6 times 6, which is 36 outcomes. But using the fundamental counting principle, on the first number cube, how many sides are there, or how many outcomes? There are 6. And on the second number cube, how many outcomes are there? There are 6, and 6 times 6 is 36. We can do that with a coin and a number cube. The coin, how many outcomes are there? Heads or tails, so there are 2. And a number cube, how many outcomes are there on a number cube? 6. So if we do a coin flip and roll a dice or a number cube, we would have 12 outcomes. Okay, so either one of these can be illustrated in a table. Okay, so this is the table with the cubes. So when only 2 stages or 2 events are used, rolling one number cube, then rolling another number cube, you can make a table. So you can list all of the outcomes for one of the items and all of the outcomes for the other item and where they overlap, 1, 1, 2, 1, 2, 1, 3, etc. You could do the same thing with the number cube and a coin flip. So you could do the number cube this way and have 1, 2, 3, 4, 5, 6. And up here you could do the coin, and it would be heads or tails. 2 outcomes there, that's it. And so you could make like heads 1, tails 1, heads 2, tails 2. Okay, that is another way to find the information instead of, tails 4, instead of using a tree diagram. Okay, but that's not completely what we're here for. We need to talk about the probability multiplication rule. So that's the fundamental counting principle. 2 number cubes are rolled once. How many possible outcomes are there for which the first roll is even and the second roll is even? Well, we know how many total outcomes there are, but that's not what they're asking. They're only asking for the outcomes where you get 2 even rolls. So how many on that first number cube are even numbers? So you'd have 2, 4, and 6. So you'd have 3 outcomes here. And on the second number cube, you'd have a 2, 4, or a 6. So you'd have 3 there. Now, I want this and this, so I need to multiply these 2 together. And I'm going to get 9 outcomes. Okay. So what is, now here's the question for you. If two number cubes are rolled, what is the probability of rolling an even number on each cube? Okay, so now we're asking the probability of doing this. So using the old way, let me say, of doing that, we would do 9 outcomes out of 36 total outcomes, which we get from here, rolling two number cubes, and we would reduce and we would get 1/4. But we can also look at it and look at each event separately. Okay, on the first number cube, what is the probability of getting evens? How many are even? 3 out of how many total? 6. And on the other number cube, same thing, it's 3 out of 6. And if we multiply these two together, we get 9 out of 36, which is 1/4. Okay, so we can do both events together, or we can treat them as separate and then multiply. And that's the multiplication rule for probability. If events A and B are independent, then the probability of A and B combined is equal to the probability of A times the probability of B. Now, independent means the occurrence of one event does not change the probability of the other. Okay, so if I roll a number cube and then I roll another number cube, doesn't matter. It's not going to change the outcome. Same with flipping coins. So let's do another example here, and in fact this is our last example. So if we have a bag that contains 2 red and 3 blue marbles, and Robert's going to pick a marble from the bag, look at it, and then replace it. Okay, that's going to give us our independent events. Then he's going to select a second marble from the bag. What is the probability he selects a red marble and then a blue marble? So let's do the probability of getting a red marble. So there are 2 out of how many total? 2 out of 5. And what's the probability of getting a blue marble? 3 out of 5. And these are independent because we replaced the marble that we took out. If we didn't, that changes things, because then our pool to pick from is fewer. But by replacing the marble, the next draw it's independent from the first one. It doesn't matter. So now if I want to know the combined probability, I multiply these two, and I get 6 out of 25. That's a probability that he gets a red and then a blue marble. Okay, little different. We could have taken this and done a tree diagram as well, or made a chart, right? We could have gone 2 red down, we could have gone red and red and blue. Nope, we would have gone red, red, blue, 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 and red, red, blue, 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 and then we would have combined them. So you could get red, red, or red, red, or red, blue, or red, blue, or red, blue, or red, red, and we'd put like this one first, red, blue, red, blue, red, blue, or blue, red, blue, red, blue, blue, etc. Okay, we'd fill in that row, those rows the same. And then, so there'll be 25 outcomes, and which ones go red, blue? Well, it's these 6. Okay, and so that's how you can illustrate that using a table or a tree diagram. But I think you'll find that finding the independent event probabilities and then multiplying them is a whole lot simpler. Okay, so just an introduction into the multiplication rule for probability. Let me know if you have questions. I'll see you in class.